Hello students, welcome to EPG Pathshala. Today we shall be discussing about the various space agencies in India. As you all know, the Indian Space Research Organization, headquartered in Bangalore, is the topmost organization for dealing with various space related achievements and tasks in India. So in this module, we shall be talking about the mission of Indian Space Research Organization, its components, its organization, and also the various satellites that have been launched. Besides, we shall also be discussing about some of the agencies such as National Remote Sensing Agency, which is now called as National Remote Sensing Center in Hyderabad, the Indian Space Research Organization, Indian Institute of Remote Sensing, and various other agencies pertaining to space. At the end, we shall also discuss the applications of these satellites and the role of these space agencies in various domains of environmental sciences. So, as discussed, the Indian Space Research Organization is the solitary governmental space agency in India with satellite launch and recovery facilities. Indian Space Research Organization is popularly called as ISRO also, and it is amongst the prime governmental space agencies in the world. Its key objective is to advance the space technology and practice its applications for the national benefit. This Indian Space Research Organization was formed on August 15, 1969 from INCO SPAR program. The founder of ISRO was Dr. Vikram Sarabhai. It's headquartered in Bangalore. Dr. Vikram Sarabhai is the father of India Space Program. He established Indian National Committee for Space Research. Soviet Union on 19th April 1975 launched Aryabhatta, the India's first satellite, which was constructed by our very own Indian Space Research Organization. It was named after the great mathematician Aryabhatta. Further, ISRO developed two rockets in 1980. The two rockets were Polar Satellite Launch Vehicle (PSLV), which was launched for launching satellites into polar orbits. The Geosynchronous Satellite Launch Vehicle was the second vehicle which was launched for placing the satellites into geostationary orbits. Further, these rockets have launched many communication satellites and Earth observation satellites. The satellite navigation systems such as Gagan and Indian Regional National Satellite Systems. The satellite navigation systems like Gagan and Indian Regional Navigational Satellite Systems, popularly called as IRNSS, have been deployed by Indian Space Research Organization. So this figure shows us the organizational structure of Indian Space Research Organization, which is under the supervision of Department of Space of the Government of India. So the following figure shows us the organizational structure of Indian Space Research Organization, which is under the supervision of Department of Space of the Government of India. As you all know, the Prime Minister is the head of this organization, and the various agencies have been shown in the figure, which we shall be discussing in the coming slides. So, coming to these components of ISRO which have been shown in the figure, the first one is Physical Research Laboratory or PRL. It is a national research institute for space and allied sciences. It is under the supervision of Department of Space and Government of India. PRL supports research in the field of astronomy and astrophysics, atmospheric sciences and aeronomy, earth sciences and solar system. It is located in Ahmedabad. Dr. Vikram Sarabhai established PRL on 11th November of 1947. The second component is NARL, which is National Atmospheric Research Laboratory. It was established to carry out research in the field of Atmospheric and Space Sciences. NARL is an autonomous research laboratory which is funded by the Department of Space, Government of India. It was founded in 1992 under the name National Mesosphere Stratosphere Troposphere, that is MST Radar Facility. Professor A. Jayaraman is the present director of National Atmospheric Research Laboratory. The third one is Northeastern Space Application Center, that is NESAC, that was established on 5th September 2000 by the joint efforts of Department of Space and the Northeastern Council. The chief purpose of the center is number 1, to provide operational remote sensing based natural resource information. Number 2, to provide operational satellite communication application services. Number 3, to set up a space science and global change research hub by installation of necessary instrumentation and networking with various academic institutions of the northeastern region of India. Now coming to the fourth component, that is Semiconductor Laboratory, that is SCL. This provides research facilities in the field of microelectronics to encounter the requirements of the country. It was previously known as Semiconductor Complex Limited, which was further named as Semiconductor Laboratory from September 1st, 2016. So, you all can say this is a very recent development. So, the main functions of this semiconductor laboratory are number 1, to create a strong research and development base in the country in the field of microelectronics, to design and develop the devices in cutting edge technology. Number 3, manufacture VLSI MEMS based systems and subsystems. And number 4, transform SCL as a center of excellence in microelectronics on the country. The fifth is IIST, that is Indian Institute of Space Science and Technology. It is located in Thiruvananthapuram, Kerala and was established on 14 September 2007. This organization deals with research in outer space. The next is ANTRIX, which was established by the Government of India on 28 September 1992 and is administered by the Department of Space. It is a commercial arm of Indian Space Research Organization. The seventh in this line is National Remote Sensing Center, Hyderabad. It was previously called as National Remote Sensing Agency, NRSA. So, NRSC is located at Hyderabad and is responsible for the distribution of satellite data products within India, besides providing training and creating awareness about geospatial technology. Now coming to the missions of ISRO, the first one is Mars Orbiter Mission, the second one is LVM-3X or CARE mission, the third one is AstroSAT Mission, the fourth one is GSAT-17 and the fifth one is PSLV-C40 or Cartosat2 series satellite missions. So coming to the first mission of ISRO, that is Mars Orbiter Mission. This mission was launched on 5th November 2013 by the Indian Space Research Organization and entered the orbit on 24th September 2014. The Mars Orbiter mission, which is known as MOM, is also called as Mangalyaan. The prime role of this mission was to find the past existence of life on Mars and to find the possibility for preparing new life on Mars. This mission will help us to study the Mars surface features, its morphology, mineralogy and the Martian atmosphere. In this Mars Orbiter mission, spacecraft of 1337 kg was launched with 5 instruments as payload. The figure shows the Mars disk as imaged by this mission on November 9, 2017. The second mission is CARE mission. For this, the launch vehicle LV-M3 was used, and it was launched on December 18, 2014 from Satish Dhawan Space Center, Shar, Sriharikota. It was placed at an altitude of 126 kilometers. So the objectives of this mission were: the first one is the flight validation of the complex atmospheric flight regime of LVM3, validation of new design feature, overall integrity of the mission design, simulation and software implementation, study the re-entry characteristics of crew model CARE. The third mission is AstroSAT Mission. This mission marked a spot in history as the first dedicated multi-wavelength observatory of India that was launched on 28 September 2015 on a PSLV XL. The satellite was launched into the space by the rocket PSLV C-30 from Satish Dhawan Space Center, Sriharikota. This had a launch mass of about 1513 kgs and was launched into a 650 km orbit inclined at an angle of 6 degrees. The AstroSat has an efficient lifespan of 5 years. So the main objectives of AstroSat mission included estimation of sources of multi-wavelength cosmic radiations. So the objective of AstroSat mission included estimation of sources of multi-wavelength cosmic radiations in hard X-ray and UV bands during sky surveys. It is also used to estimate the magnetic fields of neutron stars, broadband spectroscopic properties of X-ray binaries, clusters of galaxies and similar high energy processes in the cosmic system like active galactic nucleus, supernova remnants and stellar coronae lying beyond our galaxy. The fourth one is GSAT-17. GSAT-17 was launched by Indian Space Research Organization on 28th June 2017 and is operated by INSAT, that is Indian Satellite. This satellite weighs 3,477 kg and carries large equipments which transmit the information regarding the chemical and the physical nature of the atmosphere. GSAT-17 was launched into a geosynchronous transfer orbit, that is GTO, by Ariane 5 VA-238 launch vehicle. Later, it was replaced in a circular geostationary orbit using satellite's liquid apogee motor, which is controlled by the Master Control Facility MCF at Hassan. GSAT-17 has a working lifespan of 15 years. The next is Cartosat2 series satellite mission, PSLV C-40. This is the future project of ISRO and was expected to be launched on Friday, January 12, 2018 at 9:28 hours Indian Standard Time. PSLV C-40 will be launched in India's polar satellite Cartosat2 series with a launch vehicle of about 710 kg. The flight time of this vehicle is 40 seconds. First launch pad FLP of Satish Dhawan Space Center SGSC Shar Sriharikota will be used to launch the above said vehicle. Now coming to the spacecrafts of Indian Space Research Organization, it is a vehicle or a machine designed to fly in outer space. As you all know, spacecrafts are used for a variety of purposes that include communication, Earth observation, meteorology, navigation, planetary exploration and transportation of humans and cargo. So the main satellites that are included in this spacecraft are communication satellites, Earth observation satellites, satellite navigation, GPS aided geo-augmented navigation popularly called as Gagan, and Indian Regional Navigational Satellite System IRNSS, which is also called as NAVIC. So coming to the first one, that is the communication satellites. The Indian national satellite, which is called as INSAT popularly, is the largest domestic communication satellite in the Asia Pacific region, with 9 functionally active communication satellites situated in the geostationary orbits. It was established in 1983 with the authorization of INSAT 1B. These satellites help in disaster warning news, gathering television broadcasting, societal applications, and search and rescue operations. The second series of satellites is Earth observation satellites, which are particularly devised for Earth observation from orbit and for environmental monitoring. Other examples include meteorology, map making, and we have various other applications which we shall see in the coming modules. In 1988, ISRO has launched many operational remote sensing satellites. So at present, there are 13 satellites in sun synchronous orbit and 4 in geostationary orbits. These satellites are used for covering agriculture, water resources, urban planning, rural development, mineral prospecting, environments applications, forestry, ocean resources, and disaster management. Some Earth observation satellites include ResourceSat-2A, SCATASR-1, INSAT-3DR, SARAL, etc. The third one is satellite navigation. The Indian Space Research Organization is working jointly with Airport Authority of India for establishment of GPS-aided geo-augmented navigation, as we call as Gagan system, to meet the civil aviation requirements. For the requirements of positioning, navigation, and timing services based on the indigenous system, the Indian Space Research Organization is establishing a regional satellite navigation system that is called as Indian Regional Navigational Satellite System. The fourth series of satellites is Gagan satellites, which is GPS aided geo augmented navigation. The Indian government implemented a regional satellite based augmented system SPAS, which further implemented a GPS aided geo augmented navigation system. The project has established 15 Indian reference stations, 3 Indian navigation land uplink stations, 3 Indian mission control centers, and installation of all associated software and communication links. It will be able to help pilots to navigate in the Indian airspace by an accuracy of 3 meters. The last one in this is Indian Regional Navigational Satellite System IRNSS, which is also known as NAVIC. IRNSS is an independent Indian satellite based positioning system for critical national applications. This system is used for accurate timing, navigation, and positioning assistance in India and its neighboring countries. It will provide basically 2 types of services with the help of 7 satellites: Standard Positioning Service SPS and Restricted Service. The restricted service is for defense purpose and is not available to the public at large. 3 out of the 7 satellites are placed in geostationary orbits GEO and 4 satellites in geosynchronous orbits. The Honorable Prime Minister of India, Mr. Narendra Modi, named this group of 7 satellites as NAVIC, that is navigation with Indian constellation. Now, coming to the applications of these satellites, the first and foremost of our concern is Earth observation. So, these satellites, they collect data on synoptic and systematic information about land, ocean and atmosphere and several aspects of environment at a regular interval of time and help in studying the Earth observations. The second one is agriculture and soil. The satellite-based optical and radar images are used widely along with geospatial tools for monitoring of agriculture and generating crop models for agricultural yield forecasting, besides the drought assessment. These satellite systems can be used to estimate the crop production, the soil properties such as saline and sodic soil mapping, the agromet services, horticulture development and disaster surveillance for pests, flood and drought can also be done using the Indian remote sensing satellites. The third one is bioresources and environment. Indian remote sensing technology and or these satellites can be used for finding out the wetlands and for lands that need to be conserved. Similarly, the regions rich in biodiversity and in need of conservation or on the brink of extinction can be estimated and monitored. The fourth application is cartography, which is generally referred to as map making. The Indian remote sensing systems can be used for large scale mapping, which can be used to update the topology of a terrain. An elevation model can be created online, and such data can be shared in real time with least or no delay for use of Indian meteorology, space research, geographical research, mining and archaeological studies, and can prove to be of significance. Another important application is the atmospheric and climatic studies. The satellites are actively involved in studying the land air ocean interactions coupled with ground observations and modeling. The Earth and Climate Sciences Area ECSA of National Remote Sensing Center Hyderabad emphasizes on the study of land surface processes, climate modeling, atmospheric and ocean sciences. The next application is disaster management, which has been gaining quite a lot of attention in the recent years, as you know, due to the incidents of disasters, maybe floods, earthquakes, tsunami, and so on. So, the support programs are well studied using Indian remote sensing technology. The Indian Space Research Organization has developed various satellites to study about the prior information of natural disasters such as flooded conditions, drought, earthquake, cyclones, forest fires and landslides. Further, under Disaster Management Support Program DMSP of National Disaster Management Authority headquartered in New Delhi is working on various policies and programs to devise new methods so that the risk and losses due to disaster can be minimized before, during or after the occurrence of a disaster. Satellite communication is one another important application which has become very important and ubiquitous throughout the country for applications such as television, DTH broadcasting, DSNG and VSAT. Many initiatives are taken into consideration by Indian Space Research Organization towards social development, which includes tele-education, telemedicine, Village Resource Center VRC and disaster management system programs. To conclude, at the end of this module, dear students, you all have studied what are the various types of satellites that have been launched by the Indian Space Research Organization, what are the various components of Indian Space Research Organization, be it spacecraft, be it rockets, be it the launch vehicles. Also, we have studied about the various missions that have been launched in the few recent times by the Indian Space Research Organization. And towards the end of this module, we have studied the applications of these satellites in various domains of environmental sciences, be it forestry, where we can use it for forest fires, be it for agriculture, for soil mapping, for cartography, for telecommunication, for business communications, or for wetland mapping, monitoring, disaster management and all various others. So there are a variety of applications, the details of which we shall see in the coming modules, and this module was mainly intended to provide you an overview of these applications, the components of Indian Space Research Organization, and the various missions of Indian Space Research Organization. Thank you.